So far we've looked at parabolas and cubics. Our third graph that we're going to look at is exponentials. So, the general equation for an exponential is y equals a to the power of x minus b plus c. And just like the parabola and the cubic, a, b, and c all control similar things. So a controls the shape, and the larger the number is, the more steep it's going to be. The smaller it is, like between 0 and 1, the more stretched out it's going to be. Just like a cubic and a parabola. B is our horizontal shift. So that's left and right. And remember, just like the parabola and the cubic, positive goes to the left and negative goes to the right. And C is the vertical shift, where up is positive and down is negative. Alright, so if we were going to look at one in general, let's take y equals 10 to the power of x. Now the reason I picked 10 is because the exponential graph is directly related to the logarithmic graph. Now we haven't done the log graph yet, but that'll be coming up in an upcoming tutorial, and I'll further explain the relationship between the two. But just for now, we'll take this one as our standard one. So y equals 10 to the x. And if I'm curious what that looks like, I'll do just like what I did with the parabola and the cubic to start with. I'll make a little table of values. So if we've got x and y, and maybe I'll take the values negative 2 through 2 for x. So, on the y side, if I sub that in, I've got 10 to the negative 2. Now, if you remember your algebra, negative exponents, I'll just write it over here, 10 to the negative 2 is the same as 1 over 10 to the power of 2. So remember, a negative exponent means 1 over that same thing to a positive power. So 1 over 10 squared would be 1 over 100. As a decimal would be 0.01. 10 to the negative 1 would be 1 over 10, or 0.1. 10 to the 0, now this is another special one. Remember, anything to the power of 0 equals 1. So anything to the power of 0 is always equal to 1. The only time that's not true is if a is 0. 0 to the 0 does not equal 1. So a can be anything except for 0. So this one equals 1. 10 to the power of 1 is 10, and 10 to the power of 2 is 100. So if we were to graph these, I'm going to start by putting on x equals 0, and that's 1. So I'm going to put it right here. If x equals 1, then y equals 10, so I'm going up. Each square is worth 2, so 2, 4, 6, 8. That would put it right there. And if x equals 2, y equals 100. Well, that's way off my scale already. Going on the negative side, at x equals negative 1, it equals 0.1. So that's already maybe really close to the x-axis. If x equaled negative 2, it's 0.01. So that's even closer. And on the negative side, it's getting smaller and smaller and smaller, but on the positive side, it's quickly increasing and getting bigger and bigger and bigger and bigger. Now, when a curve is approaching a value but never actually gets to it, we like to put something called an asymptote there. So in this case, there's an asymptote sitting right on the x-axis. So that's y equals 0 is the x-axis. This thing's getting closer and closer to y equals 0 the more negative it gets. So I'll just spell that for you. So our blue dotted line there is an asymptote. Alright, let's try a couple examples. So let's do it when we're comparing it to y equals 10 to the x. And remember, in general, y equals a, x minus b plus c. So the first couple we'll do here, So let's start with y equals 2 to the x. This time I'll use the squares 1 to 1. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. On the other side, 2 to the power of negative 1 is a half. And then negative 2 would be a quarter, and so on. So it's getting bigger this way and then getting smaller this way, with our asymptote still at y equals 0. Our second one, y equals 10 to the power of x plus 4. So for this one, remember the plus 4, that's like the b, and positive shifts it to the left. So this is going to shift this to the left 4. Now, what point would be good to start on to shift? The answer to that is what's going to be the reference point for an exponential. So I'll just put it on the first one here. 0, 1 is the reference point for an exponential because it always goes through that point, because anything to the power of 0 equals 1. So if we were to shift that point, then we just move it over 4. 1, 2, 3, 4. Now it's right here. So remember, for 10, it was increasing a lot quicker. So 10 to the power of 1 was already 10. So that's already going to be quite high. Way up here already on this scale. And then on the other side of it, if I went to negative 1, that's like 1/10, 1/100th. So it's going to increase real fast there. And then on this side, look like that with our asymptote at y equals 0 again. For number 3, y equals 10 to the power of x minus 1, that's going to shift the whole thing down 1. So instead of it going through 0, 1, now it's going to go through 0, 0. Then on the other side, it's still going to get lower and lower. This time, our asymptote's been shifted down by 1 as well. So the asymptote is sitting at y equals negative 1. And then on the other side, it's blowing up very quickly. Number 4, y equals negative 10 to the x. Now, just like the parabola in the cubic, if you put a negative out front, it flips it in the x-axis. So instead of 0, 1 being a reference, now it's going to go through 0, negative 1. And it's going to get bigger negative on the right-hand side real quickly. And then on this side, it's going to go and approach y equals 0. And the fifth one, y equals 4 to the power of x minus 1 plus 2. So for this one, it's been moved. Remember, minus 1 means to the right 1 and up 2. So if our reference point was at 0, 1, so it was at 0, 1, but I want to move it to the right 1 and up 2. So if I move it to the right 1, 0 becomes a 1. But the other one was already a 1, so if I move that 2 from 1, it's now going to be at 3. So I want my reference point to be at 1, 3. That means that the asymptote is going to be 1 unit underneath it. So that's going to be at y equals 2. And then we can just draw it in from there. Alright, the next thing we're going to look at, just like we did with the parabola and the cubic, is modeling. So, given 2 points, let's say negative 1, 2, and on this side we'll go 5, 9. Now, just like the parabola and the cubic, I look at this and it looks like a ramp to me. So, if it looks like a ramp, do you remember which one we said the reference point was? It was the bottom one. So, we want the reference point to be the bottom one here. So that's going to be like the point 1, 0. So we're going to say let -1, 2 be the reference point. Like 0, 1 on the standard one. On the standard exponential. So if 0, 1 needs to be shifted to -1, 2, that means that we've got a shift. I want to go from 0 to -1, so that's a shift up to the left 1, and to go from 1 to 2 is only 1 unit, so that means I need to shift it up 1. So we need to remember that with an exponential, the c value is always going to be 1 less than where the point is, because it was at 1, so it has 1 less to move. So b is going to be equal to -1, and c, as I just said, is 1 less than the value of it. So b is going to match the point, c is going to be 1 less than the value. So if we substitute that in, so we get y equals a to the x minus -1 plus 1. So that's the same as y equals a to the x plus 1. So as we see, the formula takes care of that b value for us. Do you remember what we did with the parabola and the cubic? The next thing is, we've now got it going through -1, 2, but we haven't told it to go through 5, 9 yet. So we do that by subbing in the 0.59. That'll give us an a value that will make it go through it. So sub in 5, 9. So the y value first, 9 equals a to the 5 plus 1, and then plus 1 at the end. So I would first take away 1 from the 9, so 8 equals a to the power of 6. Now, do you know what we do to get rid of a power of 6? We do the opposite, which is the root of that number. So we need the 6th root of 8. Remember on our calculators that you can find that with that button right there. It's quite often above the exponent key, but it depends on the calculator. So I would hit 6 first, and then that button with a little x with the root, and then 8. And I got a value of 1.414 approximately. Alright, so the last thing to do is write the equation. Therefore, y equals 1.414 to the power of x plus 1 plus 1. Just like we did with the parabola and the cubic, I'd also like to put the bounds in. So for this one, the x went between -1 to 5, so we're going to write that x is greater than or equal to -1, less than or equal to 5. In the next tutorial, we'll go over the logarithmic curve and how that one works, and how we use it to model curves.